Hello students. In the last class, we have discussed regarding the two different types of motion for system of particles in the topic. In the previous topic class, we have discussed regarding the two types of motion. One is translational motion and the second one is rotational motion. For a rigid body, and we have discussed the definition of rigid body, like the body or an object which do not change its shape, of course, when the external forces are applied on it or deforming forces are applied on it. For such system or a rigid body, we have discussed the motion, different types of the motion when it is set up under the motion by application of force. In that, translation motion we have discussed, and as well rotational motion also we have discussed. And in the translational motion, any body is said to be under translational motion, or it can also be defined. The meaning of translational motion, as we have discussed in the previous class, is when a body moves on any horizontal surface, the velocity of every particle of the entire system should be the same. So that is the translational motion. Okay, that is translational motion. The velocity of the entire, all the systems or all the particles of that system of body is should be the same. That is translational. Whereas the rotational motion, the system under consideration or the body which has been considered should rotate around a fixed axis. That is called the rotational motion. It means we have a axis of rotation, that is a reference around which the body will rotate. Okay, and irrespective of shape and size of the body, the condition is it should rotate around a fixed axis. And in that, we have discussed one more concept. For any axis of rotation, if the body moves irrespective of the shape, and the irrespective of the shape, when we consider this object with respect to this axis of rotation, all the particles may get different distances, like r1, like r2, okay, and here it is r3. Somewhere here we can say that r. So whenever it is set up under the rotational motion, the body rotates either it may be in clockwise direction or anti-clockwise direction. The particles will also move horizontally. It means the plane is perpendicular to the axis. The plane of motion of this particle is perpendicular to the axis of rotation. Like this, it is the plane in which the particles will move. This is the plane that we consider. So this plane, the particle which is rotating around the axis, that plane will be perpendicular to the axis of rotation. Like this. It is just simple. Like whenever you rotate any object, okay, when I rotate this object with my fingers, so my fingers, these two fingers will be the axis of rotation. These two fingers will be the axis of rotation. Like this, when I rotate the object, so this object rotates, okay, either in this way, either in this way. Whenever the rotation takes place, the particles of this object, the particles may be present all over the entire system. So that with respect to this axis of rotation, my fingers, the object will be rotating around this fixed axis. Okay. Plane, what I am talking, the plane means when the object is moving in this way. This we consider as a plane. Like this, it is moving. Okay, this is the plane in which it is moving. Okay, so that plane is perpendicular to the axis. This is the axis. My fingers are axis. Hence, with respect to the axis, the plane of the rotational motion of the particles is perpendicular, and every particle will be lying at a different positions in the entire system. One particle is here, one particle is here, one particle is here, one particle is here. So this entire rigid body is made up of so many number of system of particles, or it is made up of so many particles which are of course close to each other. But here, for our consideration, we have taken only here and there. Some examples we have taken the particles. They are present. All the particles will be moving. And the rotational motion, whenever we consider, that is angular motion. Okay, maybe it is same. But whereas the linear velocity, angular velocity with respect to that rotational motion, all the entire system is rotating with a fixed angular velocity like this. But whereas the linear velocity, whenever you calculate, so that linear velocity is equals to r omega v right. We have a relation between linear velocity and angular velocity. So this linear velocity is depends upon the position vector. This r is nothing but the distance of particle from the axis of rotation. When I consider my fingers as the axis, then one particle may be here, one particle may be here. Hence, when I consider this particle with respect to this particle, so first particle will be at larger distance compared to the second particle with respect to the axis. This is what exactly we are putting here, the points R1, R2, R3. Okay, like very nearest particle for the axis of rotation is R2. The farthest particle is the R3 at the point R3. Next one is R1. Okay, so these are the position vectors that we are talking, and of course the masses of the particle may be m1, m2, and m3, like this. So all the particles will rotate together. It is not particle to particle. When I move this duster with respect to my fingers, the entire duster will be rotating. This is the rigid body. But here, the explanation is when a rigid body moves, then all the particles also moving along with this duster. It is not the new thing. But what exactly we are studying in this concept of rigid body and the rotational motion is, this rigid body will contain so many number of particles in it, even all the particles will move. Of course, according to the duster only, as you see, the entire duster will move, all the particles will also move. Because the particles of this duster, of course, which is made up of a wood, will not leave the duster. Because it is a rigid body, so it will be there, fixed. Hence, all the particles will move. But what we are studying is, so when consider as all the particles of this rigid body, how they shows the rotational motion and translational motion, then microscopic view, or even when you consider the positions of all the such particles, then all the particles will be moving around the axis with an angular velocity omega. But whereas all the particles may be at different position vectors, all the particles will be at a different position vectors. Okay, it is just like a gate. Imagine we have a fixed columns over here of a compound gate, a fixed columns here, and here we have hinges supporting. Then we have fixed the gates. Consider this as a door or a gate. When we hold the handles of this gate, okay, either for opening the gates or closing the gates. With respect to this axis of rotation, these are the axis of rotation of the gates. And this entire gate is one rigid body. So when I open or when I close, with a certain angle with respect to the axis. I will close and open. And angular velocity also the same. The entire particles of this rigid body will move with a certain angular velocity. With what speed I will open it, what pace I will close it. But the particles at this point, the particles at this point, or particle at this point, particle means a part of that body, will be at different positions like this. Hence, when I consider the linear velocity of such particles, okay, linear velocity, we are talking about whenever we consider the linear velocity with respect to the fixed axis of rotation, it is a center. With respect to the fixed axis of rotation, if the wheel rotates in the anticlockwise direction, like this, if the wheel is rotating, so the tangents with an arrow mark, what I have here, these tangents represents linear velocity equation or linear velocity of the particle. Of the wheel also we can see. All the tangents are linear velocity, whereas the wheel is rotating like this, clockwise or anti-clockwise, but wheel is rotating. It is rotational motion, it is executing. But if I put a tangent for every point, considering particles are there, so that is a linear velocity it is representing. It is similar to that of a playing with a simple game. If you tie a stone to a thread and rotate in a hand, it will rotate, rotational motion. So at certain point when you leave the thread, it will not rotate. Instead, where exactly it will leave or left, at that point, either it will go that side, either it may go this side, either it will come towards you, either it comes away from you. It is like at what position you have left that thread. So that is the linear velocity when you rotate like this. Suppose imagine when the stone comes here, if you leave rotating, the stone will go like this along with the thread. It won't rotate again. It will go like this. That is the linear velocity. Since a force is applied at the center, so that it is continuously changing its direction. The linear velocity is continuously changing its direction, executing rotational motion. Hence, for any object which is under the rotational motion with a fixed axis of rotation will be moving, okay, will be rotating, and hence angular velocity we are calculating, linear velocity also we are calculating. And linear velocities again depends upon the position vectors. Example is here, either you can take example of this gate or a window or a door, whatever it may be. Linear velocities, okay. So likewise, so this is the concept in the last class that we have explained, rotational motion and translational motion, and one more motion we have discussed, that is the precision. Precision means like the object should move or should have a fixed axis of rotation, as well it should have a circular motion also. It is just like a top, or even you can say that a pedestal fan. Okay, pedestal fan also, we can have a stand over here and we have a fan fixed like this. So it will be rotating. One, the wings are rotating, rotational motion, and along with that it is rotating even like this also with a fixed axis. Along the axis also it is rotating, and even translational motion also it is doing. Okay. So likewise the precision, even the top also, it will be rotating around the fixed axis and it is having a spin motion also. That is circular motion or spin along by its own axis. So that is called as precision. Okay. So here the concept of translational rotational motion has been explained, and even the linear velocity concept, and on what factor does it depend, that is the position vector of the particles. But now the next concept that where we stopped is when we consider as a particle to particle explanation. Instead of that, what now we should consider is, if an entire body is considered which is made up of so many number of particles. Again, I will take the example of this duster only. It is made up of so many number of particles. Hence, whenever it is set up under the motion like this, okay, now it is set up under the motion, or even we can consider a window at home or a door at home. Okay, So when a door is closed or opened with a support of the hinges, consider this is the door and here is the handle. It is very easy to open and close with this handle. Imagine either of these three supporting hinges. If one is removed, usually what happens? The rotation little bit difficult because the support of this axis is away from it, so that it will tries to bend like this in this direction, and of course it will get opened and closed. But even the balance, we can see that the balance, okay, the orientation, earlier it was like this straight, now the orientation is like this, it has been become, so that even the bottom portion may touch. In case even second are also removed, then definitely this door, instead of standing like this, it will fall in this way, orientation. This edge will touch the ground and still it will be difficult to move with a proper angular velocity. So the position vectors, it means along the axis whenever it rotates, then it executes rotational motion. And whenever you start rotating, okay, so that linear velocity, the particle to particle what I am talking now, it is not possible to have a rotational motion. Instead what we are supposed to do, we have to remove this and take the door and keep it somewhere. Then that is only displacement it will be. Okay, so that here as an entire body we have considered. But now whenever the one hinge or second hinge or even any one of the hinges will be removed, we can see that the door will bend, it will stand on only the third hinges. The supporting is only this one, the supporting point, which means the entire door of it may be 10 feet or 8 feet, whatever may be the length, the entire door will be supported by the last support, this last hinge. It will not fall until we remove this one. So entire weight of this door is balanced only at this point. Same concept. Now the next one I am explaining is the entire mass of the object. Imagine this is the duster. Entire mass of the object, it may be 5 gram or 10 gram. The entire mass of the object, whenever it is set up under the rotational motion, okay, a point in this entire body, anywhere, it may be not exactly at the center, it may be or exactly at edges, where, how and which axis of rotation it has. Based on that, we find all the particles. This is the duster which is rotating. All the particles are there of mass m1, m2, m3, m4. So many particles are there at distances r1, r2, r3. But a point, a mass will be there, a point where it is considered to be the entire mass of the object is supposed to be concentrated at that point, and that is called as center of mass. Center of mass of the system. Like this example, when first second hinges are removed, the door definitely will bend, but it won't fall down because the door will be balanced at this point. That is the last stage. Hence, the entire weight is balanced at this point. That is weight I am talking. But here, whenever we consider such kind of the rigid bodies, okay, in the entire system of the rigid body, all the particles are there at different positions with respect to the axis of rotation. Somewhere it is found where the entire mass of the body is concentrated at that point. It may be at this point, it may be at this point, it may be this point, it may be this point, anywhere. Okay, at that point, with respect to the axis of rotation at a particular distance, the entire mass of the body is supposed to be concentrated, and it has same rotational motion as the entire body will have. That point is called as center of mass. Okay, so same example if I take and if I write as the axis of rotations, x-axis, y-axis and z-axis. When I consider x, y and z, imagine with respect to the origin, Now the object or this system or this door or the rigid body is rotating in the space. Now it is rotating. It is a fixed axis and it is rotating in the space now. So that it is in the space means three-dimensional space it is. Then we should have coordinate system. The coordinate system is consists of three axes, x, y, and z axis. Hence, when I put the three coordinate system picture x, y, and z axis. Okay, for the same axis of rotation along y axis, along x axis, along z axis. It is rotating now. Okay, it is rotating now. Imagine we have two particles of the system. Only two particles I have taken. Of course, it is made up of so many number of particles. I will take only two particles of the system. Okay, it is at point A and it is at point B. And these two particles are at a distance of r1 and at a distance of r2. Position vectors. First particle is at point A, second particle is at point B. Of masses m1 and m2, of course. Okay, and these two particles are at a distance of r1 and r2 as this picture. m1 is here, m2 is here. Okay, two particles, one is here, another particle is here. With respect to the coordinate system, when I consider, then at the origin, along the origin, because the axis of rotation at every point we have a certain distance from the axis of rotation. So that in the three-dimensional space, when I consider, then I should consider the origin O. In this regard, like r1 and r2 will become position vectors of particle at point A and particle at point B, which is set up under the motion by applying external forces. Imagine it is external force F1 acting on it, and it is another external force F2 acting on it. For the two different particles, the two forces are acting, external forces, to set up under the motion. When these two external forces are acting in the system, then as we know that within the system also internal forces do exist. Okay, internal forces means the first particle exerts a force on the second particle and the second particle exerts a force on the first particle. Okay, both the particles also execute forces or exert forces on each other. That is called as internal forces. Okay, this particle will act towards the second particle and this particle acts towards the first particle. So this what we can write as F12 and F21, which means the force on the first particle due to second particle, force on the second particle due to first particle. That is internal forces we can say. And external forces is F1 and F2. Likewise, the forces are acting on the system so that it is set up under the motion. So as the particle starts rotating or moving due to the application of forces, when these two particles start moving, then they execute velocities, and those velocities are defined as v1. Okay, velocity is written as displacement divided by time taken. Hence, these velocities I will write in terms of position vectors. That is dr1 divided by dt, and v2 is equals to dr2 divided by dt. Rate of change of displacement, or we can say that rate of change of distance. Okay, first thing, second particle velocities, two velocities of the particles by the application of force. So that in F1 and F2 what I represented is external forces. Now the internal forces are represented by F12 and F21, and now the net force whenever I calculate Okay. As per the Newton's third law, the forces when acts on each other, it is equal and opposite. Then we can write F12 is equals to F21, but it is in opposite direction. That is minus, and I can write over here. E is equals to minus. But whereas net force when I write F12 plus F21 E is equals to 0. Whereas net force when I write, net force is nothing but external force plus internal force I should write. So that is F1 plus F12, that is first particle, plus F2 and plus F21, it is on second particle. This can be written as F1 plus F2 plus F12 plus F21 separately. So this is for external plus internal force on first particle. F2 plus F21 is external plus internal force on second particle, because two forces are acting, external and as well as internal forces. Hence I should add external and as well as internal. As we are the second, Newton's the third law we have discussed, F12 plus F21 is equals to 0. Hence net force we have written F1 plus F2 only. And according to Newton's second law now, the force has been defined in the Newton's second law as the rate of change of momentum is directly proportional to the applied force. Okay, rate of change of momentum. So momentum, linear momentum, usually we write mass into velocity. Hence, here the forces we should take as per the Newton's second law. The rate of change of momentum is directly proportional to the applied force. So for that, in external plus internal is on first particle, external and internal on second particle is same. Like we can rewrite the same as, otherwise we should have since, consider this is equation 1, since external plus internal on first particle, we can write according to Newton's second law, that is d by dt of mass into velocity m1 v1. Similarly, f2 plus f21 we can write as d by dt of mass into velocity of the second particle. Since anyhow f12 plus f21 is equals to 0, so that f1 plus f2 is nothing but the same. Hence, whenever we add F equals to net force, we should add these two, that is F1 plus F2, which is nothing but d by dt of m1 v1 plus d by dt of m2 v2. So net force we are adding external plus internal on the first body and external plus internal on the second body. Okay, so d by dt of this one. So this can is nothing but d by dt of m1 v1 plus m2 v2. We can write as the net force on the system, and that net force is nothing but f1 plus f2. The same what we have written is f. Okay, that is f1 plus f2 only. Now slightly we should modify this, and that modification is f is equals to d by dt of m1 into, like v1 we have written earlier as r dr by dt and v2 as dr2 divided by dt. Hence m1 is as it is, d by dt is as it is, v1 is dr1 divided by dt plus m2 into dr2 divided by dt. what the small changes or modification in the equation we did is, first, as it is F1, F2 is nothing but rate of change of momentum of first and second particle due to the application of forces we have added for this system of two particles. Okay, M1 V1, M2 V2 represents momentum of first particle, momentum of second particle. Since we are calculating the forces, and force according to Newton's second law is rate of change of momentum. Hence, rate of change of momentum, d by dt of momentum, d by dt of momentum. It is rate of change of momentum. Now, this has been represented, total momentum, change in momentum is due to the net force. But again, the same equation when I rewrite, d by dt of momentum. But this momentum is also has a velocity concept or the velocity parameter. So that velocity is written as dr by dt. That is position vectors of two particles. First particle is at a distance of r1, second particle is at a distance of r2. Those two particles, by the application of force, may execute rotational motion. Anyhow, consider that they are rotating or moving anyhow. But under that motion, what we are trying to calculate is when they rotate by the application of force, or when they shows the translational motion, rotational motion due to the application of force, or when they set up under the motion due to the application of force, the point in the entire mass, the point in the entire system will be there that we are calculating where the entire mass is supposed to be concentrated. So that dr1 by dt, dr2 by dt is nothing but velocity only we are taking separately, only velocity concept. Hence, here what we can represent as differentiation for the momentum we did, differentiation for velocity concept we have taken. So yes, the mathematical terms are there. Differentiation of this total momentum and differentiation of this velocity concept, that means displacement, which gives you the velocity. Hence, if I take this differentiation common, then it is d square by dt square, it will become d square by dt square for m1 r1 plus m2 r2 we can write. But anyhow, the mass will not change, even the position vector is also the same. Okay, the mass will be the same, only d square by dt square. It means when I do double differentiation for the displacement, will gives you the acceleration of the velocity. Okay, the same thing, double differentiation we are doing. Double differentiation for the displacement. Okay, d by dt means velocity. Again, d by dt of velocity is force. That is momentum we are considering. That is the two steps we are supposed to understand. Double differentiation we are doing now. Okay. So for this, now let us consider for this multiplying and dividing by m1 plus m2 on RHS side. Here we have force on RHS side. We should multiply and divide by m1 plus m2, that is total mass of the two particles. So that F equals to, consider it as equation 2, m1 plus m2 multiplying and dividing, that is d square by dt square as it is, m1 r1 plus m2 r2 divided by m1 plus m2. It is divided by m1 plus m2 and multiplied by m1 plus m2. These two will get cancelled. Again, the same equation we get. There is no change in the equation 2. Only slight modification what we did is the two particles total mass we have considered. Okay, so that m1 plus m2 and multiplied and divided by this concept. Okay, so now let us consider this. So let's consider in this entire system a point C in between at a distance of r, where this radius vector or position vector r at point C with respect to the origin considered to be the center of mass of these two particles. Okay, so that is given by F is equals to m1 plus m2 into a, that is mass into acceleration is nothing but force of these two particles. The next equation. Up to this, we have taken for only two particles. Now, we have considered together these two particles by the application of force. There is an acceleration which is F is equals to mass into acceleration we have taken. Okay. And here, this mass into acceleration we can rewrite as m1 plus m2. Acceleration is d square by dt square of position vector, and that position vector is r, as dr by dt, and d by dt when I multiply this d square by dt square of r, which is gives you acceleration, velocity, and the next is momentum, is nothing but rate of change of velocity is acceleration. The same acceleration is here, because as we know that a is equals to v by t, whereas v equals to s by t, so that s by t square, that is double differentiation of position vectors is nothing but acceleration, that is d square r by dt square is center of mass cm identified. So this r represents position vector, okay, center of mass of these two particles at point C. There may be center of mass due to the particle m1 and due to the particle m2, but there is no another particle I am talking about. Only these two particles may have their center of mass at the point C, which is at a position of r, capital R, that is distance r, center of mass. At this distance the center of mass exists. Okay, so it is just like to understand the center of mass. If I want to balance this duster on the single finger, it may not balance like this, it will fall. Even if I hold, it will fall. But somewhere, if I could manage exactly taking this duster at this point with respect to two fingers, then somewhere it is possible me to hold this duster, which means the entire mass is supposed to be concentrated at this point. If I slide slowly, if I move this duster at this point, then definitely it may not be possible me to hold this duster at this point, because it will fall, or not even at this point like this also it will fall. It means it is not exactly the center I am talking, since the duster I take an example. So here it may stop, correct? It means properly I can hold this duster. So it means this is the point where the entire mass is supposed to be concentrated. And with respect to this position, if I rotate, the angular velocity remains the same. Okay, that is the concept of center of mass. Let us consider this as equation 3. Okay, so here we should compare F, these two equations. Here also we have F, and here also we have F. Okay, then comparing, let us consider this is equation 3 and this is equation 4. LHS are the same. When I consider RHS, then m1 plus m2 we have, m1 plus m2 we have, d square by dt square we have, d square by dt square also we have. Then in place of RCM, it means comparing 3 and 4. And I compare equation 3 and equation 4. In the LHS, net force. On the RHS, m1 plus m2, m1 plus m2. d square by dt square and d square by dt square. Here RCM, position vectors of center of mass. And in place of R, what we have? m1 r1 plus m2 r2 divided by m1 plus m2. Which means the center of mass RCM is m1 r1 plus m2 r2 divided by m1 plus m2. This is the expression for center of mass. Okay, we have compared up to this, just we have taken the two objects or the two particles of the system, then forces are applied. Hence, up to this equation, it is okay. Two forces acting, that is internal and external forces on individual particles. Net force we have calculated. Because of that net force, the entire system of particle M1 and M2 may get under motion. So that because of this force, these two particles of masses M1 and M2 together may have some acceleration. So that F is equals to M into A we have written. So this equation as it is written M1 plus M2, acceleration can be written as d square by dt square of r. Or we can write acceleration is dv by dt, rate of change of velocity, as it is. The next d by dt as it is I will write, and v can be written as ds by dt, that is rate of change of position, is nothing but velocity. Hence together what we can write is d square by dt square of s is nothing but displacement of the position. So this r, instead of s we have taken r over here. So acceleration can be written as double differentiation of position. That's what A is equals to dv by dt according to the definition of acceleration, rate of change of velocity, as it is dv by dt. So d by dt as it is I will keep, and velocity can be written as rate of change of position or rate of change of displacement, ds by dt. So together what we can write, d square by dt square of position or d square by dt square of displacement. Same thing I have mentioned. Acceleration is d square by dt square of position vector r. This r is considered to be the position of center of mass. R is position of center of mass. Hence you write CM, center of mass of these two particles from the origin to the point C. This is the distance, like R1 and R2 what we have taken. Same position is R for the center of mass of these two particles. Somewhere here the center of mass may exist, and that position is R. Distance is R from the origin. Find for that R, we have calculated the equation, center of mass equation. M1 R1 plus M2 R divided by M1 plus M2, like this. In case, okay, we'll continue in the next class regarding the same center of mass and how it will vary with respect to the variable masses or same masses. Thank you.